Welcome to the lecture of mass transistor. In the previous lecture, we have seen mass transistor and its operation and its characteristics. Let us see use of that mass transistor in this lecture as pass transistor. You are going to learn and understand the pass transistor concept in this lecture. The contents are pass transistor, nmos pass transistor, pmos pass transistor and a transmission gate. Mass transistor switch action we have seen in the first lecture. Let us see once again the switch model of the mass transistor. We have in the mass transistors two transistors, one is nmos and another one is pmos. This nmos and pmos are acting as switches in the on mode and off mode depending upon the voltages applied at the gate terminal. So this is the nmos transistor and it is the pmos transistor. This nmos transistor, when gate connected is with high voltage, that is logic high, then it will act as on switch, means it will just act as short circuit. Similarly, when at the gate is applied with 0 volts, this nmos transistor is off. Off means it is open switch, means simply it is acting as open circuit. So now based on this switching action, the switch may be shorted from this end to this end or open this end to this end. We can use this to pass a voltage from one terminal to the other terminal, or we can stop the voltage from one terminal to the other terminal in off mode. So using this action, we are going to use this nmos transistor as pass transistor, means which is passing a signal from one end to the other end when it is in on condition, and it is not passing the value from one end to the other end if it is at the open condition. The same action is applicable for the pmos transistor also, whereas pmos transistor passes a value when the logic 0 is applied at its gate, and when logic high is applied at its gate, the switch is in the off mode, therefore it is not passing the signal from one end to the other end. So using this switch behavior, the mass transistor can be used as pass transistor. Let us see the pass transistor concept and its types. There are two types, one is nmos and pmos, therefore both can be used as pass transistors. So we are having of nmos pass transistor and pmos pass transistor. Let us see about nmos pass transistor. First, nmos pass transistor. Here we are taking a nmos transistor symbol and its output is connected with a load capacitance, and let us take initially load capacitance is 0. Let us take load capacitance is initially discharged, therefore V out is equal to 0, and Vs is equal to VDD. We know Vs is equal to VDD or logic high, then only this nmos transistor is on. Then apply the Vs as VDD and connect input signal as logic 0 or logic 1. First, for input logic 0 is applied, then this pass transistor, because of applying at gate, this is on and this passes 0. Therefore, the capacitor is discharging fully, so V out is equal to 0. If input voltage is taking as VDD, then this transistor passes output as VDD minus VT only, not the full voltage. So for 0 it passes 0, for VDD it passes VDD minus VT, where VT is threshold voltage, where VT is threshold voltage. That is, that behavior is represented here. When gate is connected with VDD, then only this nmos pass transistor is on. Then if input 0 is applied, it passes as it is 0. When input VDD is applied, it passes VDD minus VTN as the output voltage. Means NMOS transistor passes strong 0 and weak 1. Because logic 0 is as it is passed as 0, but VDD is passed as VDD minus VT. Therefore, it is calling as NMOS pass transistor characteristics as it passes a strong 0 as it is 0, and weak 1 means if VDD is applied, reduced voltage than the VDD is passed at the output. Let us see the PMOS pass transistor. This transistor is acting as a pass whenever this transistor is on. So on means at gate we have to apply logic 0. So Vs bar is equal to logic 0. Then this PMOS pass transistor is switched on. When it is switched on, then Vin will be passed to the Vout. So if Vin is equal to 0, it passes as VTP, and when Vin is equal to VDD, it passes as VDD exactly. Means this PMOS pass transistor passes strong 1 and weak 0 and weak 0. So this is the characteristics of PMOS transistor. That means whenever 0 is applied at the gate, then only it is acting as a pass transistor, and if input applied is 0, then it is passing as VTP. If input applied is VDD, then it is passing as it is as VDD. Let us check why it is coming as VTP and why it is coming as VDD in the PMOS pass transistor, and in NMOS pass transistor why it is coming as 0 as it is 0 and VDD as it is as of VDD minus VTN. Means this is the source terminal always, and it is the gate terminal. VGS is nothing but the voltage difference between gate and source. So since 0 is applied, here VDD is the gate potential. Gate minus source, this is equal to VDD. So gate potential is VDD and source potential is 0. The difference between gate and source, that is equal to VGS, is equal to VDD here. Means this VGS is greater than VT of the transistor. Therefore, this transistor is always on for the value of input 0 applied. Therefore, whatever the signal 0 is there, that will be passed as it is. Now, let us coming for this case. Gate potential is VDD and source potential is also VDD. Then VDD minus VDD is equal to 0. Then this switch is going to be off exactly at VDD volts. Then off means open. So VDD is not going to the output side. Therefore, in a sense, output is never becoming VDD. So it is not equal to VDD only always. And then what is the value which is passing here as a maximum value? Maximum value is always this difference should be minimum equal to VT. So minimum, when it will become VT difference, gate potential is always VDD, we can't change it. So input potential is VDD minus VT. Then if the signal value is VDD minus VT at the source, at the gate VDD, now the difference between gate and source VDD minus VT is equal to VT. Therefore, VGS is exactly equal to VT. So till this case, this transistor will be on. So it passes the value of VDD minus VTN. That is the case with NMOS transistor. Because of having the switch off condition at input is equal to VDD at the source terminal, it is not passing the VDD value as it is. So it is defining as weak 1. Similarly, in the PMOS pass transistor also, if 0 is applied at the source and at the gate 0 is there, VGS is again 0 here, the difference is 0, but minimum voltage required to make switch on of this PMOS transistor is VTP. Since 0 is lesser than the VTP value, therefore this transistor is off So off means the 0 is not as it is passing. Then what is the maximum value existing here or maximum value passing here when this is going to be switched on? So this transistor is going to be switched on till the input value of making the difference of VGS is equal to of VTP. Therefore, at the value of VTP, 0 minus VTP difference is VTP, then it will be non-condition. So therefore, VTP is passing. So VTP is the maximum value for logic 0 is applied for the PMOS transistor. Whereas with the VDD voltage here at the source and gate, since the difference of 0 and VDD is VDD, that means minus VDD, and its magnitude is greater than of VTP only, therefore it is always switched on for the value of input signal VDD, so it will pass as it is VDD to the other end of the transistor. So its characteristics are defined as, since 0 is not passed as it is called as weak 0, and 1 is passed as it is called as strong 1. So these are the characteristics of the NMOS and PMOS transistors. So these are the characteristics of NMOS and PMOS transistors. Now let us check some examples of pass transistor networks which are passing values from the input to the output. See the first example, it is NMOS pass transistor. See the first example, it is NMOS pass transistor with source terminal is connected to the VDD. Then what is the output? Output is nothing but, since this NMOS pass transistor is not passing full VDD, output is equal to VDD minus VTN value. Now let us check the other network which is having of series connection of pass transistors. Here 3 NMOS pass transistors are connected with one end input side is VDD connected. Since all the gates are connected to the VDD, all these transistors are on and the voltage which will go to the maximum side is equal to VDD minus VTN. How it is VDD minus VTN means, since VDD is applied here, the first pass transistor passes VDD minus VTN because till VDD minus VTN this transistor is on and later this transistor is off. So VDD minus VTN is the output for the first transistor. Now VDD at the gate of the second transistor, VDD minus VTN is the source potential. The difference between these two is VDD minus VTN. So therefore it will become as VTN. It is greater than of VTN, therefore it will switch on as it is, same voltage will pass. Then take the next transistor with the gate VDD with the source of VDD minus VTN. The difference between these two is equal to exactly VTN. So it is minimum voltage required for the transistor switch on, therefore it switches on, and as it is a source signal, pass it to the output end. So output is equal to VDD minus VTN. Like this, whenever we are having series connection of pass transistors, it will produce one VTN loss, VDD minus VTN only. Here in the example 3 transistors are represented. Even though if we have 5 transistors or 10 transistors in series, it will produce only loss of 1 VTN. So output voltage is equal to VDD minus VTN for the input of VDD. Whereas if input 0 is applied, the same 0 will be passed. There is no doubt in the 0 because it produces strong 0 for the series connection of the pass transistors. Next, let us see the third example. It is PMOS pass transistor with gate connected to the VSS and source connected to the ground. Just now we have seen as the operation part of the pass transistor. Since if 0 is applied at the source, it will pass as VTP only because till VTP, this VGS difference is VTP which makes the transistor on. Therefore, it passes VTP only Otherwise the transistor is off, so it doesn't passes the value, therefore output is equal to VTP only. Let us see the example circuit of the pass transistor network. This is the example of AND gate. We can use these pass transistors for constructing of the logic gates or any logic functions. For the AND gate, if you are using this transistor based on the truth table, we are going to construct this AND gate. So let us take AND gate with input AB, output F, 0, 0, 0, 1, 1, 0, 1, 1 are the 4 combinations for the AND gate if it is a 2 input, and output is equal to 0, 0, 1, because when 2 inputs are 1, then only output will be produced as high. From this truth table we can understand that, suppose if B is taking as a control signal and A is taking as the input, A is input and B is control signal, then if B is equal to 0, what will happen? If B is equal to 0, the signal output is equal to 0 only. If B is equal to 0, then F is equal to 0 only from the truth table. If B is equal to 1, what about F? If B is equal to 1, F is equal to signal A only. So use this principle and construct the circuit. For this one pass transistor, for this case, and for the second case also one pass transistor. So using of 2 pass transistors, and in this figure 2 pass transistors are nmos type, therefore those switches has to be switched on for the control signals of 0 and 1. So for the 0 case, it is going to be taken as B bar. So when B is equal to 0, pass transistor T2 will be on. For B is equal to 1, pass transistor T1 will be on. When B is equal to 1, T1 will be on and T2 is off. So T1 is on means it passes A. So that is, this function is satisfied. Next, if B is equal to 0, that is nothing but B bar is equal to 1, then T2 is switched on. Therefore, 0 is passed to the F. So it satisfies this function. So this AND gate truth table can be achieved with the help of the pass transistors connection in this fashion. Means with the help of 2 transistors we are going to construct AND gate. Like this we can construct any logic function based on the truth table, starting from the NOT gate to AND gate, OR gate and all the gates, universal gates, logic gates and logic functions, even some complex functions also. Then the advantage of this use of pass transistor is nothing but just it uses few transistors when compared to the static CMOS and other logics. In this example, it uses just 2 transistors for the AND gate. If it is the same AND gate, if you are realizing with the CMOS means, it will take 6 number of transistors. Whereas here 2 transistors only used. That is the main advantage of the pass transistor. But what is the problem? Problem is nothing but when B is equal to 1, signal A is transmitting. But A may be again, when B is equal to 1, A is transmitting, but A is either 0 or 1. If A is 0, no problem, it will passes as it is as strong 0. But when A is equal to 1, it doesn't passes as strong, it passes as weak 1. And remaining 2 cases, anyway output is producing 0 only, no problem, for this 0, it passes a strong 0. So all the 3 cases are strong values except the 1 value. That is, when input is equal to A signal is equal to 1, it passes as weak 1. This is the problem. So because of this problem, what is happening? It cannot be the input for the other gate. Means in the cascading, suppose if a next other gate is there, if another gate is connected here, means for one case it is producing as VDD minus VTN, whereas it requires 1 means VDD value. Therefore, it produces the error itself in the next case. So, it cannot be used in the cascading stages because of the voltage loss problem. So this is the remark of the pass transistor. Advantage is less number of transistors are used, but disadvantage is produces weak 1 in the output if it is the nmos, weak 0 in the output if it is pmos. Therefore, in the cascading connections, it is not preferable. So, the remedy for that is how to avoid that voltage loss problem or degrading of the voltage problem is nothing but it is overcome by using of one solution that is called transmission gate. So, by combining the behavior of nmos and pmos transistors, we can construct a transmission gate. Combining means two transistors nmos and pmos are connected in parallel. So, this is the parallel connection of nmos and pmos. This is the pmos transistor and then this is the nmos transistor. Both are parallelly connected, means both sources are connected and both drains are connected, and at the gate terminals control signals are applied. At the gate of the nmos will be connected as the control signal yes, and then at the pmos it has to be connected as S bar, because these two are complementary signals and complementary transistors. To make these two at a time simultaneously, complementary signals need to be applied at the both gates. Now what will happen? If 0 is connected at the input, then as it is 0, Vout will be passed as 0. Why? Because means this nmos transistor passes the strong 0 through the nmos transistor, even though there is a loss in the pmos, but that loss is nullified by the nmos transistor. So 0 is passing strong by the nmos. When input is VDD, that is passing as VDD only, not the VDD minus VTN, which is a problem in the nmos, because here because of this pmos transistor is switched on and it passes a strong value to the other side. So for the input of 0 and VDD, output is also having of 0 and VDD. So there is no voltage loss. No voltage loss. By combining the advantages of both the transistors, we are getting the advantage in the both logics. That is the transmission gate. There is no voltage loss, there is no voltage degradation. So instead of pass transistor, we can use this transmission gate everywhere in the all applications. I hope you understood the pass transistor concept. Now, to check our understanding, let us check this quiz. First one, find the output values for following the pass transistor networks. The first two pass transistors are connected in series, and at the source or at the input, ground is connected. Then what is the output? Output is nothing but simply because these two are nmos, this passes a strong 0 only. So at this node output is 0 and the 0 is again passed to the as 0 because both are connected to the VDD. So for the network A, output is equal to logic 0. For the second one, at the input 0 is applied. This is the PMOS pass transistor. At the gate 0 is connected. So this is on. What it passes? It passes as VTP, and that VTP is connected as input to the second pass transistor with source connected to the 0. We know that with the input of 0, this pass transistor is not passing full. It passes anyway 1 VTP when gate is connected with 0. But now this gate is not connected to the 0. This is connected to the VTP value. Therefore, still one more VTP is going to be reduced. So output is equal to 2 VTP here. That means 2 times VTP is dropped from the 0 value. So output is 2 VTP for the second case. Then for the third, one PMOS and one nmos are connected in series with the 0 connected at the input side. This PMOS transistor passes VTP, and since it is on nmos transistor, anyway it passes full value of lower level value. Therefore, output is equal to VTP value for the third case. And here we are representing all our mod values. That means all we are seeing in the magnitude only. Next, the fourth case, pmos and nmos are in series. This is a P and this is N. And P passes full VDD since input is connected to the VDD. And now nmos passes degraded VDD by the VTN. So output is equal to VDD minus VTN value. So for the fourth case, output is equal to VDD minus VTN value. This is the first question. Take these are as the assignment questions. Find the values at the intermediate nodes and output node. And for this also find the value of x and x bar values. Follow the textbook of this Essentials of VLSI Circuits and Systems by Bucknell. What we have seen till now? We have seen pass transistor concept. Means nmos transistor or pmos transistor, when these two are acting as on switches, can be used as pass transistor. And this pass transistor is used to reduce the number of transistors in a circuit. But what is the problem with here? It doesn't drive the next state. They are not capable to drive the next stage at the fullest level, because whenever they are connected in cascading, because they are having a problem of voltage degradation or voltage loss by the VT voltages. Therefore, the remedy for that is using of transmission gates, and other remedies are also there which we have not discussed here. Those are nothing but using the level restoration techniques and multiple threshold transistors. We will see all these in the next levels. I hope you understood the pass transistor concept and use of pass transistor as an example, and pass transistor networks output voltages when something is connected, when pass transistors are connected in the cascading mode. Thank you.